a little much. If you want to see the proof, you can totally see it in the book. Okay, so sine, sum, and difference. So we just learned the cosine, sum, and difference formulas. We saw the cofunction ones. And now we're going to learn the sine ones. So here's the sine ones. Again, you guys will always have these on an exam, so you don't need to memorize these. So again, this is super helpful for figuring out the sine of 75 degrees. We can do the same thing that we did for the cosine, where I can take 75 degrees and write it as 30 degrees plus 45 degrees. So that gives me, using the sum formula, so that's going to be the sine of 30 times the cosine of 45 plus the cosine of 30 times the sine of 45. So this is a little complicated, so you've got to make sure, I always tell students on a test is double check everything when you're writing these out. Excuse me. So the sine of 30 degrees is 1/2. The cosine of 45 degrees is root 2/2. And then the cosine of 30 degrees is root 3/2. Sine of 45 is root 2/2. So I get root 2/4 plus root 6/4, which is root 2 plus root 6 all over 4. And that does not simplify. Same thing here. When I look at this, you can see that this matches up with this difference formula. The sine of 20 times the cosine of 80 minus the cosine of 20 times the sine of 80. So this I can rewrite as the sine of 20 minus 80, which gives me the sine of negative 60 degrees. Okay, so negative 60 degrees is going to put me in this quadrant 4, so sine is negative there. You look at your little chart, the sine of 60 degrees is root 3/2. 3/2. So it's negative square root of 3/2. Okay, so these types of problems you're going to see are going to be really similar to what we did before in chapter 5. But in this case, we're going to have two angles. So here it tells us the sine of alpha is 3/5. So that means that we've got our y value is 3, our r value is 5. We can figure out what our x value is by doing that x squared plus, let's just do it. X squared plus y squared equals r squared. So we get x squared plus 9 equals 25. So I get that x squared equals 16, so x equals 4 for alpha. So for alpha, we know that it is between pi/2 and pi, so that's where alpha is going to be. And for alpha, again, we've got our y, r, and our x. And then it's told me that beta, so again here, we've got my y, my r. We can find our x value, so x squared plus y squared equals r squared. So x squared plus 1 equals 5, x squared equals 4, x equals 2. And beta is in this quadrant between negative or 3 pi over 2 and 2 pi. So when I'm asked to find the cosine of each of these angles, well, I've already done the work for it. Remember that cosine is always the x over r. So for alpha, we know that alpha is in this quadrant. Cosine is going to be negative in that quadrant. So it's going to be negative 4, because that's the x, over the r, which is 5. For beta, all right, so cosine for beta. So cosine in this quadrant is going to be positive. So this is just going to be x over r, positive. So the x value we found was 2 for beta, and the r value was the square root of 5. So multiply both the top and bottom by the square root of 5, and I get 2 root 5 all over 5. Okay, so now that I know that the cosine of alpha is negative 4/5 and the cosine of beta is 2 root 5 over 5, now I can use these sum formulas to find the values of the cosine of those two angles added together and the sine of those two angles. So I'll use my cosine formula, sum formula. So that equals the cosine of alpha, cosine of beta, plus, I always do this, minus the sine of alpha, sine of beta. So the cosine of alpha is negative 4/5. Cosine of beta is 2 root 5 over 5. Sine of alpha is 3 over 5. Sine of beta is negative root 5 over 5. So this gives us negative 8 root 5 all over 25 plus 3 root 5 all over 25. When I combine these, negative 8 root fifths plus 3 root fifths leaves me with 5 root fifths. And then that's all over 25. And that simplifies. I can cancel the 5 out here. We can't cancel anything inside of the radical, but I can cancel a 5 out with a 5 down there. So that leaves me with root 5 over 5. All right, over here, using the sum formula, that's going to give me sine of alpha, cosine of beta, plus cosine of alpha, sine of beta. So that gives me sine of alpha was 3/5. Cosine of beta is 2 root 5 over 5, plus the cosine of alpha, which is negative 4/5, times the sine of beta, which is negative root 5 over 5. So that gives me 6 root 5 over 25 plus 4 root 5 over 25, because a negative times a negative is a positive. I'm going to go over here. So 6 root fifths plus another 4 of them leaves me with 10 root 5 over 25. And I can cancel a 5 out of the top and the bottom, and that leaves me with 2 root 5 over 5. Okay. So sum and difference formulas for tangent are these. And just have the summary of all of them. And again, you don't need to memorize any of them, which is super rad. There they all are.